All right, so now we get into the next cases, which is when the angle's outside the circle, and also I think probably in this video we'll cover the case when the angle is inside the circle. I think I could fit them both in one. The last video was 17 minutes long, and I think that, and that's with you getting time to answer the questions. It was probably more like 45 minutes long or 40 minutes long. So in this particular case, we're dealing with angles outside the circle and angles inside the circle. Now, this first diagram here, this is made up of two secants. A secant begins on the circle, goes through the circle to a point on the outside, or you could look at it as a point on the outside, goes through the first point where it touches the circle, and then stops on the second point where it touches the circle. So that's a pair of secants. This middle diagram is a tangent because it touches the circle just once, and the secant from a point on the outside because it touches twice. And then the third one, they touch, that's a pair of tangents. So it doesn't really matter if it's made up of secants or a secant and a tangent or two tangents. The bottom line is if that angle is located outside the circle, it's half the difference. If you notice, all three formulas have a minus sign in them. It's a half the difference of the arcs. So if it's on the circle, it's half the arcs. If it's outside the circle, it's half the difference of the arcs. Let's try some sample questions. Remember, the measure of the angle is half the difference of the arcs. So the angle is half the difference of the arcs. Go ahead, give it a shot. Okay, so the angle's outside the circle, so it's half the difference of the arcs. That's 1/2 of 125 minus 27, which is half of 98, which is 49. You try this one. Again, angle's located outside the circle. So, oh, you know what? Can we just change this a little bit? Because I misread this the first time. I'm going to ask you to redo this. Can you make this 20 degrees the measure of the arc on the inside, the measure of arc JP? I did not see that that was pointing to the angle. So let's make it the measure of arc JP. So redo, please, with it being the measure of arc JP. You may have done that the first time and misread that as I did. Okay, so the angle is outside the circle. So the measure of the angle is half the difference of the arcs. So it's half of 70 minus 20. Remember, I had just asked you and said that that 20 should be the measure of JP. And that makes it half of 50, which is 25. Okay. Now we get into one that's a little on the tricky side because of the x's. Follow the formula through very logically. Go ahead. Okay, these questions do an outstanding job of really getting you to think about the structure of the formula. So the angle is outside the circle, so the measure of the angle is half the difference of the arcs, which in this case means that the measure of the angle is going to be half of 4x minus 9 minus 55. And that angle then is going to be half of 4x minus 64 because minus 9 and minus 55 is minus 64. But that angle then, because the angle here, we have it listed as x, right? Because they said the measure of the angle is x. But to get rid of that 1/2, I'm going to multiply both sides by 2. Now you could distribute the half, but I prefer to multiply it by 2. And that gives me 2x equals 4x minus 64. Subtracting the 2x, let me take that back. I subtracted the 4x from both sides. 2x minus 4x is negative 2x is negative 64. Divided by negative 2, I get x equals 32. If you chose to distribute the x instead, you would get the same exact answer. Now, this may look different to you, and I'm not trying to sound snotty, but it doesn't look different to me. The reason it doesn't look different to me is because it's still an angle outside the circle, so I still have to remember that the angle is half the difference in the arcs. So it's still the same case. Go ahead, give it a shot. Okay, so the angle's outside the circle. Whoa. I guess I didn't do the solution to this. So let me do it now verbally. 240 minus 120 is 120. And then I have to cut that in half, which will give me 60. So 240 minus 120, half the difference in the arcs. The difference is 240 minus 120 is 120, and half of that is 60. Okay? This one I did write the answer for. So go ahead, give it a shot. Okay. Now, this, I think, is a tricky question. And a lot of times students need to be shown this once before they can really begin to get these right. Actually, no. It's a variation off of this that's trickier. So look, if this inside arc, what we call the minor arc from B to D, as opposed to the major arc from B to D, which is the one that takes the long way around, if the minor arc's 140, the major arc will be 220, because together they have to add up to 360 degrees. So if the inside arc is 140, the outside arc is 220 because they must sum to 360 degrees. But since the angle is outside the circle, it's half the difference. So the measure of the angle is half of 240 minus 1. Oh, that should be 240 minus 140. I put 120 down there for some reason. I guess I misread the two. Well, you know what? I got lucky. I like had a dyslexic moment where I inverted the 140 and the 220. But let me correct it. Again, I am utterly incapable of doing something perfectly right every single time. So 220 is the outside, minus 140 is the inside. Half of that is 80, half of 80 I should say, which makes 40. And let's go back to play. And I get 220 is the outside one, right? Because the inside arc's 140. So together they have to add up to 360, which makes the outside arc 220. So the measure of the angle, x, which is on the outside, is half the difference of the arcs. So 220 minus 140 is 80. Half of 80 is 40. So that's the measure of the angle. All right. Now we got two questions for you to do. The last one is the one that's really challenging. The first one, very straightforward. The second one, very challenging. Go ahead. Okay, I do trust that you have been and will continue to always do stop and start. So the angle is outside the circle, which means the measure of the angle is half the difference of the arcs. That's 110 minus 30, which is 80. Half of 80 is 40. This one, however, is very challenging. And there is a chance that you tried hard. I would expect you to try hard, but that you didn't come up with the answer. So I'll show this to you, and I'm sure we'll encounter it a couple of more times before the end of the year. So the first thing I notice about arc X and arc Y is that together they make up the whole circle. Okay? Now the angle's outside the circle, so we know it's half of the difference. We also realize, in addition to X plus Y adding up to the whole circle, so X plus Y has to be 360, since this angle is 38 degrees, that represents half of whenever I subtract them. So when I subtract X minus Y, I have to get 76. I have to get 76 because half of 76 would give me the 38 that I was looking for. So together, X plus Y add up to 360, and X minus Y has to be 76. So I have a system of equations here, and if I just add them up, I'll get rid of the Y's because one is plus and one is minus the same amount. So 2x is 436, dividing by 2, x is 218. Okay. Now, if x is 218, y has to be 142. This way they sum or add up to 360 degrees. Now, what do we have here next? Well, we've just covered up a whole bunch of questions where we did the angle outside the circle and examples where the angle was half the difference in the arcs. Now we segue to the angle being inside the circle, and it's half the sum of the arcs. So what I want you to notice in this diagram is you have angle x here, okay? And angle x has a vertical angle on the back side of angle x. So here's your vertical angle right here. Together, those two angles intercept the two red arcs. So the measure of x will be half the sum of the arcs. Basically, it's the average of the arcs, okay? So let's get into a couple of examples. Let's try just the first one. I'll go through this with you, and then you get to try the second one afterwards. Now, in case you think you know it, try the first one. And if you don't get it, I'll go over it with you. Go ahead. Okay, so angle x is inside the circle. It's going to be half the sum of the arcs. What arcs? Well, the arc directly across from angle x, which is 54, and the arc directly across from its vertical backside, which is 32. So the angle's inside the circle. The measure of the angle is half the sum of the arcs. So it's half of, remember, the angle, the arc across from it, which is 54, and then you do its vertical angle, and the arc across from that, which is 32. So 54 and 32 add up to 86. Half of it is 43. Okay. Try the second one. Now, a little forewarning here. They ask for angle x. Well, that's great. But one way or another, you're going to have to take a roundabout way of getting it. I think the most straightforward at this point in time, roundabout way to get it is to realize that if I find where I wrote the word angle, if I find that angle, then it's the supplement of that angle. So go ahead. Okay, so the angle's inside the circle, so the measure of the angle is half the sum of the arcs. What arcs? Well, the angle we're looking for, it says angle right there, the arc is 107. On the back side, its vertical component, the arc is 19. So it's half of 107 plus 19, half of 126, which is 63. But to get x, it's the linear pair to 63. So I got to do 180 minus 63, and I got to get 117. Now, there are other ways to do that. You could realize that since 107 and 119 add up to 126, and that's two of the arcs of the circle, and the other two make up the whole circle, then 360 minus 126 would be 234, and then the x would have to be half of that sum. Half of 234 is 117. I don't know too many people who might have wanted to start it that way, but you could. Okay, go ahead. This time we throw a little x in there. So we see that x in there, and all it means is just to be a little more methodical with the formula. So the measure of the angle, because it's inside the circle, will be 1/2 the sum of the arcs. So let's just write that out. Angle's inside the circle, so the measure of the angle is half the sum of the arcs. So the measure of the angle is half of 5x plus 10, because the arc on the one side with the 40 is 5x. Then there's the vertical angle. Arc on the back side is 10. So the measure of the angle, 40, is half 5x plus 10. So there's my 40, which is the measure of the angle. Now I'm going to multiply both sides by 2 to get rid of the 1/2, and I get 80 is 5x plus 10. Subtracting the 10, and I get 70 is 5x, dividing by 5, and I get x is 14. Now, you may think before when I chose not to distribute the half and instead to multiply the other side by 2. Why did I do that? It's because of a situation like this. If I can get rid of the fraction before distributing, I don't have to worry about if the 2 goes into the 5, which it would not have. It would have given me a decimal. And decimals, 2.5 is not that bad, and you do have calculators, but I'm still not as comfortable with decimals. Okay. Now, the next thing I wanted to talk about was just the simple case of the central angle. The measure of the angle with a central angle is always equal to the arc, because if you put all the central angles together back to back to back to back to back, you get 360. If you put all the arcs together back to back to back to back, you also get 360. So the measure of the angle is equal to the arc. How this jives with what we just talked about, with an angle in the middle being half the sum of the arcs, if you do a perfect central angle, then its vertical angle the part behind it will also be a perfect central angle. So it will be the same all the way through, okay? It only works this way with a central angle, that it equals the arc. So if the measure of angle P in the next diagram is 84, what's the measure of arc AB? Well, that is also 84. And there's that not correct arc symbol that we showed you what it looks like properly, but there it is. Okay, a chance to kind of put it all together here. What's the value of X? Okay, so since 50 degrees is the measure of the central angle, the arc is also 50 degrees. But the angle inscribed is only half the arc. So the measure of X, the inscribed angle, is going to be half of 50, or 25. So what is our summary about these arcs? Well, if the angle is on the circle, the measure of the angle is half the arc. Now I put a little asterisk there because there is an exception to that. I'm not positive we're going to come across the exception, but when a secant meets a chord, you need to go 3 angles of a triangle or linear pair. I don't know if we'll get there. If we do, we'll certainly cover it. If the angle is outside the circle, then the measure of the angle is half the difference of the arcs. If the angle is inside the circle, the measure of the angle is half the sum of the arcs. So real simple. On the circle is half the arc, outside is half the difference, inside is half the sum. The measure of a central angle is equal to the measure of the arc. And as I said before, there is an exception, but we're not going to cover that today. That, folks, finishes off lesson number 12.